The traditional way to provision NetApp storage is one component at a time. For example, if you were going to configure your storage for Windows file shares, you would create your SVM and then your volumes, and then you would configure your shares. And if you required a particular performance level, you would also configure storage QoS as well. In this lecture, you're going to learn about application-aware data management and balanced placement. This is an application-driven process that you can use, which will automate a lot of that work for you. Application-aware data management uses the application page in the System Manager GUI to simplify provisioning storage for your particular application. You enter details about that application, and the wizard will then provision volumes, LUNs, CIF shares, etc. with the recommended settings. So the things that the wizard are going to provision is specific to that particular application. For example, if it was for Windows file shares, it will configure the shares for you. If you were configuring SAN storage for a particular database, then it would configure the LUNs. Suitable storage QoS settings are also applied, as well as all the other settings, such as the volume and the other settings we just mentioned previously. So that's your application-aware data management. There's also balanced placement that works with that. Balanced placement ensures that the volumes will be created on the most suitable node and aggregate, which can provide the required size and performance. So when you configure this, you enter details about the particular application, including the size of storage that is required and the performance level that is required, and then System Manager Wizard will do the rest for you. So the settings you're going to enter are specific to a particular application. The different applications that are available by default in the GUI right now, if you're configuring this on a NAS SVM, are just a standard general NAS container, also Oracle, Oracle RAC, Microsoft SQL Server, virtual desktops, and virtual servers. And if you're configuring this on a SAN SVM, all of those options are also still available, and an additional one is MongoDB. So when you configure this, you need to have created the SVM first, because when you run the wizard, you specify the SVM that this application is going to be in, but everything else after doing the SVM is going to be auto-magically done for you by the wizard. So you put in settings such as the size that is required. You also enter a QoS service level as well. So for each application you configure using the wizard, you specify whether the performance required is value, performance, or extreme. And actually, if you're configuring a database, for the different components of the database, they'll be in different volumes. For example, the log file will be in its own separate volume, and you can configure different performance levels for the different volumes that make up that database. So the first one I mentioned there is value. This guarantees the lowest level of performance, so it's suitable for things like email, web, and file shares that don't require high performance. The expected IOPS per terabyte, so this is using adaptive QoS, is 128. The peak IOPS per terabyte is going to be set to 512, and the expected latency when you use this service level is up to around 17 milliseconds. The next service level is performance. That is suitable for databases and hypervisors which do require a higher level of performance than your general applications. The expected IOPS per terabyte is 2048. The peak IOPS per terabyte is 4096. The expected latency is up to 2 milliseconds. And finally, you have got the extreme service level. This is for your highest performance apps that require low latency. Expected IOPS per terabyte is 6144. The peak IOPS per terabyte is 12288. And the expected latency is up to 1 milliseconds. Now, obviously, you need to have the required hardware to be able to provide this underlying everything. But when you do, what this wizard is going to do is it's going to look at your available nodes and aggregates. Balanced placement is going to put the volumes on the most suitable node and aggregate, and the service level is going to sort out the storage QoS settings for you. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also, check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.